Hello everyone. In today's video we'll be demonstrating how to synchronize animations on objects that are part of the same hierarchy. That is to say, if you control the playing animation of a parent object, any child objects will play their related animation as well. For our purpose, the two important parts in the code are the creation of a viewport to render the world's content to the screen, and the creation of a single scene object, and that will in turn lead to the creation of every other object we need for this demonstration. Let's now go to the data, which is also known as the config. Right now we have an empty scene. As you can see, when we launch the game we get a black screen as a result. So let's add an object as a child of our scene, and that will be a robot. This robot will have an animation set which will define which animations can be played on that object and how they can transition from one animation to another. Let's call it robot anim set. In this example, all the animation frames are stored on a single sprite sheet. We can therefore set the texture at the animation set level, and it'll be shared by all of the animations in it. Let's set a default duration of 0.1 seconds and a default size of 16 by 16 pixels for all of our frames. Note that this value, like any other animation set value, can be overridden at the animation level or even at the frame level if need be. All our animations in this example are made of 8 frames, laid out horizontally inside the sprite sheet. They therefore all fit inside a 128 by 16 pixel rectangle. We'll define that as our texture size. We'll also set a centered pivot while we're here. Now let's add our first animation, front. The front animation starts at the very top left corner of the texture. Hence its texture origin is 0 by 0 pixels. Seems working, however a bit too small. Let's scale the robot up. Much better. Now let's add the remaining animations, one for each direction. Front can loop onto itself or be interrupted to transition to back, left, and right. Back, however, can loop onto itself and be interrupted to transition to front. We'll do the same for left and right, which means transitioning from left to right, for example, will go through the front animation. However, both transitions will happen during the same frame, and so it won't be noticed by the player. The back animation starts at pixel position 128 across and 0 down. The left animation starts at pixel position 0 across and 16 down, and the right animation starts at pixel position 128 by 16 down. Let's reload and see if everything's in working order. We can play around with the robot by using the embedded console. We can retrieve the robot object. Let's change its animation to left. Now let's change it to right. Perfect. And now we'll spawn 4 robots instead of one for each direction. We'll add robot 1, 2, 3, and 4 as children of the scene. In order to see the animation on the robots, we're going to use a track that will run as soon as the robots are created. To do so, we add a track list, and we'll put that in the common robot section. Robot 1 will be in the top left corner playing the front anim. Robot 2 will be top right with the back anim. Robot 3 bottom left with the left anim. And finally, robot 4, bottom right, with the right anim. Let's restart. Okay, everything looks good. We'll add a last robot that will change animations randomly. Let's list all the animations we want to use in a property called AnimList. Given that each animation has 8 frames that each last 0.1 seconds, we'll add a looping track that will execute an animation change every 0.8 seconds. Let's restart again. We can see the robot in the middle randomly changing animation at the end of every cycle. In order to showcase animation synchronization, we'll now add a child object to the robot, some booster flame. We'll place the flame slightly below and behind the parent robot. We'll also use an animation set named Flame Anim Set. Animations for this flame object are organized in the exact same fashion as for the robot. However, they are in a separate texture. We can therefore simply use the same base animation set and only override the texture itself. Let's check our work. We can see the flames, however, they're all playing the front animation regardless of what the robot animation is playing. We want them to be synchronized. To fix this, we simply need to change the setAnim call to a recursive one. The first Boolean parameter, set to false, which means we don't want to force an immediate interruption to the animation. The second Boolean parameter, set to true, means the call is recursive through all the children. After restarting, we can now see the flame plays the animation in sync with the parent. Let's see if we can make it more obvious by adding a green tint to the left animation. Unfortunately, this also affects our robot. In order to do some animation overrides for the flame only, we'll use a prefix in its animation set. The animations are still using the same name at runtime, however, when defined we can prefix them to override some of their properties. Let's add some colors to the back, left and right animations. Alright, let's restart. Looks great. We could do overrides at the frame level as well if we wanted. Let's make the second frame of the right animation both bigger and with its original color. By setting commands in the key event property, they'll get executed every time the frame is played. We'll scale up the object 1.5 times bigger. And then in frame 3, we'll restore its former scale. Let's check the result of that. If our flame animations weren't exactly set as the robot ones, for example with a different layout, we'd use similar local overrides to define them just as we did to change the colours. In this video we've barely scratched the surface of AUX's animation system. However, that should give you a glimpse of how powerful and flexible and basically how easy it is to use. And thanks for watching.